This tutorial is a thermal analysis of a plate being cooled. The plate is at an initial temperature of 250 degrees Celsius, when it is immersed into an oil bath of temperature 50 degrees Celsius. Change the analysis type to 3-dimensional, thermal transient. The duration of the analysis will be 7.5 minutes, which is 450 seconds. So type 450, for the number of time steps, and 1 for the time step. At the bottom of the graphics area, a timeline is displayed. Its length is the duration of the analysis. If any temperature loads are applied, the graph will show the period and value, over which it is in effect. The slider in the timeline will be needed when the results are being viewed. A cross-section of the plate's thickness will be modeled. Use the New Node Tool button to create the 4 corners of the cross-section. The model's length along the y-axis is arbitrarily chosen, as temperature will not flow along that direction. The New Element Tool button is used to create a single element over the cross-section. To subdivide the element, select the element's face, then use the Custom Refine tool. Right-click the component in the outline tree, to assign the elements a material property. In the Geometric tab, specify the thickness as 1. Switch to the Mechanical tab, select Isotropic, and type 2707 for the density. Switch to the Thermal tab, select Isotropic, type 204 for the thermal conductivity, and 896 for the specific heat. Activate Select Nodes. Drag to select the nodes on the left edge. Hold down the Control key and drag to select the nodes on the right edge. Activate Select Faces. The edges are now selected. Right-click Loads and Constraints, then select New Convection. For the ambient temperature, type 50, and for the heat transfer coefficient, type 80. An initial temperature needs to be applied to the entire mesh. Select the whole mesh, then right-click Initial Conditions, then select New Temperature. Type 250 in the text box. Next, solve the model. To display the results, click the temperature in the solution section of the outline tree. The slider can now be used to display the result at any time step of the analysis. If you click a node, the graph displays the change in temperature occurring at that node, over the full duration of the analysis. At about 440 seconds, it reaches a temperature of 200 degrees Celsius, which matches the expected value. This ends the tutorial on transient thermal analysis. A step-by-step explanation of this analysis is available in the beginner's PDF guide.